Hello, I'm Shahana and I will be explaining Rolle's theorem and the mean value theorem.
Rolle's theorem and the mean value theorem. First, let's look at this graph. Here in the graph, we have point A and point B, and these points are also called x-intercepts. And as we know, the function gets the value of 0 at the point of x-intercepts. Therefore, f of A is equal to f of B and is also equal to 0. And between these points A and B, we have point C. In the function, the slope of the line which is drawn to the tangent the point C is equal to 0. Why? As we know, the slope of the line is equal to tangents of the angle between this line and the positive direction of x, which here we called alpha. So the slope of this line is equal to tangent alpha. And the slope of this line will be equal to tangent of this angle. And this line is parallel to the x-axis. Therefore, between this line and the x-axis, we don't have any angle, so the angle will be 0. Therefore, the slope will be equal to tangent 0, which is equal to 0. Rolle's theorem. So what does actually Rolle's theorem say? It says that suppose that y equals f of x is continuous at every point of the closed interval a and b and differentiable at every point of its interior ab. If f of a equals f of b, then there is at least one number c in ab interval at which f prime c is equal to 0. So first it is said that we have three hypotheses here. First one is f of x is continuous at every point of closed interval ab, and it is differentiable at every point of open interval ab, and f of a is equal to f of b, then we can say that we have at least one c in ab at which f prime c is equal to 0. Why do we say we have at least one c? Let's look at this graph. Here we have a point here and point B here. So it is also f of A and f of B. Therefore, we can say f of A equals f of B. And between these points, we have several points C1, C2, C3, where f prime C1, f prime C2, f prime C3 are equal to 0. Therefore, Rolle's theorem says that we have at least one point, but it could be more than one. But Rolle's theorem make sure that we have at least one point. Okay, let's look at this example. Show that the equation x cubed plus 3x plus 1 equals 0 has exactly one zero solution. So first we need to find the interval where this solution might be in. Let's take x equals -1, and when we substitute, we will get -3. And let's take x equals 0, and when we substitute in the function, we will get f of 0 is equal to 1. First one is less than 0, and second one is greater than 0. And by the intermediate value theorem, we can say that at least one root we have in this interval, -1, 0. If we want to show that that is the only real solution, we have to use Rolle's theorem. So if we get the derivative of this given function and we'll be able to find some c, it means that we have more than one real solution. So let's take the derivative of this function. It will be 3x squared plus 3. And as we know, x squared will be always greater than 0. And when we multiply by 3, it will be always greater than 0. And when we add positive number, it will be always greater than 0. Therefore, we have found that here f prime x is never 0. Therefore, we cannot find any c in which the prime function of the given function will be equal to 0. So f has no more than 1, 0. And if we want to look at the graph, as we will see, this is -1 and this is 0, and the function crosses the x-axis in this interval only once. Next example, it says that if x equals x squared minus 4x plus 8 on the interval 0, 4. And it says verify that this function satisfies the clear hypothesis of Rolle's theorem on the interval. Then by Rolle's theorem, there exists at least one value c such that f prime c equals 0. Find all such values of c. First, what was the first hypothesis of Rolle's theorem? It was f of x is continuous on the given closed interval. So as we can see, this is the polynomial, and there isn't any number that this polynomial cannot get. Therefore, their function is defined on for all their numbers, and it is continuous for specific interval 0, 4. F of x is differentiable on open interval 0, 4. So let's look at its differentiation. F prime x is equal to 2x minus 4. And there isn't any number that this x cannot get. Therefore, we say that it is differentiable. And f of 0 might be equal to f of 4. Let's plug. When we plug, we will get 8. And when we plug 4, we will get again 8. So f of 0 is equal to f of 4 and is equal to 8. Therefore, it means that we have f prime c, which is equal to 0. Here, let's write c in the prime function. It will be 2c minus 4 equals 0. And when we solve, we will find c equals 2. So we have found that c, which is 2. The mean value theorem. It says that suppose that y equals f of x is continuous on a closed interval a, b, and differentiable on the interval interior a, b. Then there are at least one point c in a, b at which f of b minus f of a over b minus a equals f prime c. So it says that f of x is continuous on the closed interval and it is differentiable on the open interval ab. Therefore, we have this formula that we can find f prime c in ab interval. So let's look at this graph. As we can see, f prime c is the same with slope function, like y2 minus y1 over x2 minus x1, which is equal to slope. So if we draw this tangent line, and it will have some slope, and if we find f prime c, which is f of b minus f of a, this whole part, and over b minus a, this is this line, we will get f prime c. And f prime c is actually equal to slope of the tangent, which is drawn at point c. It is not the slope of the same line, but the slope are the same. Since they are parallel, the slope of the line, which is drawn at c, is equal to f prime c. Let's look at the example. It says I find the value of values of c that satisfy this equation in the conclusion of the mean value theorem for the function f of x equals x squared plus 2x minus 1 and interval 0, 1. So b is 1 and a is 0. When we plug in the function, we will get f of 1 equals 2, f of 0 equals -1. And next, we need to find the derivative of the function, which is 2x plus 2. So if we plug all the values, instead of b, we will write 1, and instead of a, we will write 0. F of 1 minus f of 0 over 1 minus 0. And f prime is equal to f prime c. If we plug all the values, f of 1 is equal to, f of 0 is equal to -1 over 1 minus 0. And f of c is equal to, we will write c in the prime function instead of x. It will be equal to 2c plus 2. If we solve, we will get c equals 2c plus 2, and from here c will be equal to 1 over 2. We have found the value of c, which is in the given interval and satisfies this equation. Next, it says that does the function f of x equals x power 2 over 3 satisfy the hypothesis of the mean value theorem on interval -1, 8. What were the hypotheses of the mean value theorem? First, it should be continuous on the closed interval. As we can see, there isn't any point that there isn't any value of x that this function cannot get, since it is cube root, so we don't have any restriction on the x's that it can get. Therefore, it is continuous on this specific interval too. And is it differentiable? Let's find its derivative. Its derivative will be 2 over 3 times x power -1 over 3, and -1 will be written in the denominator without the negative sign. So as we know that we cannot have any 0 in the denominator. So it is this function, this derivative is not defined at x equals 0, and the x equals 0, the point 0 is in the given interval. Therefore, it is not differentiable in the given interval. So we say that it is not differentiable. As a conclusion, we say that this function does not satisfy the hypothesis of the mean value theorem on the given interval. So that was it. Bye.